done. Okay, before last week, not last week. So another before the last week we don't have the class. So because of the our we have the public holiday. Right. So before that, so we already cover until the K-maps lah. Until the K-maps, that means cannot maps lah, or we call it K-maps. Normally until the midterm test will be covered until chapter 1 until the K-maps lah. Okay, so now we are at 2 p.m. So I will check how many students. Okay, so currently we have 14. So maybe we wait another 2 or 3 minutes. Okay, maybe we wait another. I think maybe 2 minutes lah. Okay, 1 minute or 2 minutes. Okay, then we can start our lecture for today. Okay, so today I'm planning to finish on the chapter 2 and also cover will be chapter 3 part 1. Because of chapter 2 already finished actually, so we already cover until the K-map before this. So just before we go for the chapter 3, maybe just some refreshment on the chapter 2 so that you can refresh what we learned before this. Then we go for the chapter 3. Chapter 3 part 1. Chapter 3 part 1 is also very similar like 2.8 is the combinational logic circuit. Right, so you can see here actually the chapter 3 will be is the combination logic circuit. So this one is just a basic the basic how you combine the we have for example we have more than 2 logic gates, so how you can combine. I think also we already cover for the basic logic gate lah. For example, we have the Boolean expression, how you can draw the digital circuits, and from the digital circuit how you can get the Boolean algebra already covered before this. Hopefully you can remember. Remember, for example, if we have the something like this. Okay, some example. Okay, one A and B. Okay, for example, this is a C. Right, and then this is this simple example lah. So hopefully, okay, from this one, from the digital circuit, at the end you have to know how to get the output lah, the output X. Okay, for example, this one A, B. Okay, so this the output here will be A plus B. So the output here will be C bar, and then this one will be A plus B plus C bar. Okay, so this we call the Boolean expression or Boolean algebra lah. Okay, so this one is the digital circuit. So from this one, hopefully from the Boolean expression, you have to know how to draw the circuits. Okay, because of this part also similar. Okay, also same lah. Also will be on the chapter 3 part 1 lah. Also the same as a chapter before this lah, on the basic logic gates. Yeah, I think we can start now. So for the lecture today. So Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to all of you. Right. So before I will start for our lecture, let me refresh. Okay, not refresh. Let me remind. Okay, soft reminder for the midterm test. As you can see in the slide, boleh nampak? Can you see the information for midterm test here? Alright, so already decide. So the midterm test, our subject is on 6 May. Okay, 6 May 2021. Alright, so the time will be 8:15 p.m. Okay, so this one will be Malaysia time. So I know some of you not now currently it's not in Malaysia, so you have to refer on the Malaysia time lah. Okay, this one I think we have maybe some of your friends not in Malaysia, so maybe you can contact me to deal the time for this one. But it will be start at the time will be start at the same lah. Maybe because of this time, some of your part in your country maybe will be Maghrib. Okay, but it's not suitable to answer the final, so I will delay lah for you. Okay. But this one you have to mention to me. Okay, so the topic for midterm tests, okay, will be covered for chapter 1 and 2. Chapter 1 will be numbering, okay, numbering system, and chapter 2 will be it will be Booleans, okay, it will be Boolean algebra, So okay, so this is for midterm test, okay, only 2 chapters, will be chapter 1 and chapter 2. All right, so today we try to finish on the chapter 2. I think almost done. Before this, I already cover for until the K-map. Sometimes we call it K-map lah. K-map, ataupun cannot match. So this is the already cover for before this lecture. And then the last is the combinational logic, logic circuit lah. Also, actually, this is a chapter 3. So that's why, so this one we can skip. Will be covered on the chapter 3. So you refer this one. Actually, the chapter 3 is the combination logic circuit. Okay, part 1 lah. So that's why this part I will explain in the fastest time lah. So it will be not in detail for this one. Actually, it's similar like this one that I mentioned to you. So I think it will be covered until on this on the something like theorem of the Boolean algebra. So how you can from the Boolean algebra you can draw the logic circuit, and from the logic circuit you can get the Boolean expression or Boolean algebra. So that's actually in the will be also similar with the combination logic circuit lah. Right, so let's go. So this is some basic logic gate. Okay, so you have to not gate. So just refresh. So refresh. We learned before this. Okay, so I just okay. This one is the OR gates. Okay, and gate. So this is that basically is the basic basic logic gates. And also we have the Nand gates, and also we have no gate. So that I mentioned to you, and Nand gate and NOR gate actually is the universal, okay, universal gate lah. That means this universal gate we can imitate to function as the for example like OR gate or AND gate or NOT gate. So we be covered for chapter 3 lah actually. Okay, this is a exclusive OR. Then this is exclusive NOR. Right, so I just skip this one. Okay, so this is a combination logic circuit. So that's why I mentioned to you. Also, on chapter 2 already covered actually. So on this one, on the 2.2, Boolean expression of the combination logic circuit. So for example, we have the circuit here. So at the end, you have to know how to get the output here. For example, we have here is the AB. Alright, so this one AND gate. Make sure you have to know what is the output for AND gate. A dot. So you can also write like this: A dot B. Or A equal A and B is up to you, or BA is the same. Okay, it's the same. And then this one will be A, B, bar. Okay, this one A plus C. So this one will be A, B bar plus A plus C. Okay, something like this. So this is we call the combination logic circuit. That means combine more than one logic, more than one logic, that we call the combination logic circuit. Okay, from the logic circuit, so this one we call the digital logic circuit. So we can get the Boolean expression, and also if we have the Boolean expression, also we can get the digital circuit. Okay, this one already covered before this. Okay, so on this chapter 2, we have the theorem for the Boolean algebra that I mentioned to you. So we have the rules of Boolean algebra. So the function of rules, this is we have the 12 rules. That means we have to simplify. If we want to simplify our Boolean algebra, we can use the rules, the rules of Boolean algebra, or we can use the De Morgan. So this is another technique. Okay, we have two techniques. Okay, to simplify, to simply. Okay, to simplify. Okay, to simplify our our Boolean expression. So we can use the rules, okay, or you can use the De Morgan, or another one we can use the K-maps. So there is two techniques that we can use to simplify our Boolean expression. First, we can use the rules. Okay, But the rule you have to know lah, which one the rule that related to the Boolean expression that you can use and then or you can use the De Morgan lah, De Morgan. So De Morgan we have two theorem. Okay, so the keyword for the De Morgan is the break the bar, change the operator lah, change the operator. Okay, so this is the law on the Boolean algebra. Alright, so this one will be skip. Okay, so this one this is the De Morgan you have to know the Morgan, break the bar. So this one break the bar. Okay, we have break here. Okay, and then change the operator from add. Okay, this one is add will be multiply. Okay, for example, if this one we change the break the bar here, and then we change the operator to the this one is the multiplication to the add here. So this is the De Morgan theorem lah that will be used for the combinational logic circuit. Right. So this is the technique that you can use to simplify your Boolean expression or Boolean algebra. Okay. So this one. Okay. Then okay. For example, this one simplification using the Coulomb theorem. Okay. So you can. Okay, I will skip this one. Okay, this one using the De Morgan. So after this, make sure you can refresh back while you are learning before this. Okay, so this one is the standard form that I mentioned to you for digital electronic. We have two standard form. First, we have the SOP. Okay, SOP is the sum of products. Right, so that I mentioned to you. So you have to remember. So this one we call the standard SOP. And this one is the SOP. Okay, this one is standard SOP. This one is a SOP and it's not standard because all these Boolean expression don't have the odd element. For example, this one we don't have the C, D, E, F, G, H, G, K, H, L, and so on. Okay, so this one we have the element A, B, C. This one also we have A, B, C. So this one we call the standard SOP. So the output for SOP is the 1. Okay, the 1. And then for another one, the another standard is the post. Okay, post product of sum. Okay, product of sum, the output will be 0. Okay, that's why you have to remember lah. Alright, so this is a post lah. Okay, the post. So this is a format of. Okay, but this is not the standard lah. But this is a post. Okay, if the standard, so that means here we have the element A, B, C, and also this one we have the element A. For example, we have a element B here. So this one we call the standard. Okay, we call the standard post. Okay, product of sum. Right, so the output for this one will be inverse for the sum for the SOP. SOP, the output will be 1, but post will be 0. Okay, so that's the things that you have to remember. So this important that I mentioned to you. So if you use the SOP, that means we will produce the output will be 1. Okay, if you use the post, the output will be 0. So on the KMAT after this, I will show if you use the post. If you use the post, okay, so you have to circle on the output 0. Okay, compare that if you use the SOP, so that means the output will be considered on the 1. Okay, so this is a truth table. Okay, if you want to develop the truth table, right, so make sure first you have to develop the standard SOP or standard post. First step, you have to, if you get the Boolean expression, make sure. So this Boolean expression is the standard SOP or standard post. Okay, if not standard, you have to convert first, and then after you convert first, then you can draw the truth table. Okay, the truth table. Okay, so this is some example. Alright, but you have to remember for the post. Okay, if you have bar here, so automatically we know the output here will be 1. If no bar here, so the output will be 0. So will be inverse in the, for example, for the SOP. Okay, A will be 1. A bar will be 0. So this is different between the SOP and post. That you have to remember this one. If the question in terms of the post, so make sure the output will be 0. The output will be 0. And then for the A bar will be 1. A only A is the 0. This means the post will be considered on the 0. Okay, so this one, this is some example. For example, this is a standard. Okay, for example, this is a standard SOP lah. So you can see this one, standard SOP. So all element we have the ABC, 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 and then first we know we have three elements. Okay, three elements, and that means we have three ABC. So 2 power of 3 we have 8. That means here you can see we have from 0 to 7. That means 8 lah. Okay, we have 0 to 7. This one you can convert from decimals to binary. Okay, binary. So this one, for example, 1, 2, 3, 4 until 7. So this one you can convert into binary. That's why you can get 0, 0, 0, 0, 0, 1, 0, 1, 0. That means here will be 2. This one will be 3. Okay, for decimal, and this one will be 4. And then from this one you have to know lah. So this one will be, for example, this one 0, 1, 1. Okay, 0, 1, 1. Okay, 0, 1, 1. For example here, actually this is a bar B C. Right. So the output will be 1. Okay, that is how from SOP, from the Boolean expression, SOP standard, you can develop the truth table lah, the truth table here. Right. Similar like post, similar like post. Right. So, but the output you have to consider on 0. Okay. For example, this one. Okay, this one will be 0. Okay, 0, 0. Okay, for example, this one 0, 0, 1. Okay, and then this one will be 0, 1, 0. For example, it's a difference between the SOP and post. Okay, so this one I will skip first. Okay, and then we go for the K-map. Okay, so the K-map that I mentioned to you is another technique that we can use to simplify our Boolean expression. So normally I prefer if you have you get the Boolean expression, the equation you want to simplify the equation. So my suggestion, you have to use the K-map. It's very simple very simple compared than if you use the rules or De Morgan techniques For if you use the De Morgan or use the rules, so that's why at the end of the last of Boolean expression, make sure it cannot be simplified yet. Okay, simplified. You cannot simplify. That's the last answer lah. Okay, if you think okay this equation can be simplified, so still cannot so still you have to try to find the rules that you can simplify. Okay, but if you use the K-map, automatically the output will be simplified equation. That's why my suggestion, you have to use the K-map lah. Okay, so that mentioned to you. All right, so make sure so you have to remember. So for example, this is a 3 variable. We have ABC. Okay, also you can write like this. Okay, so this one in the vertical. Also you can write as the horizontal lah. For example, like this one. Okay, for example, this is horizontal. Also can. For example, you want to declare this one is the AB and this one AC. So 0, 1. Okay, 0, 1. This one 0, 0. 0, 1. Okay, this one make sure 1, 1, 1, 0. Okay, make sure this one will be different. Okay, so normally if the normal sequence, suppose 1, 0, suppose 1, 0, but using the K-map, make sure you have to remember this one. Okay, we have start with the 1, 1 and 1, 0. So similar like if you have the 4 variable 4 variable here. So this is a sequence 0, 0, 0, 1, 1, 1, 1, 0. Okay, similar like this one. Also you can change. For example, if you want to put CD, AB, also same. Don't worry. So it's also same. Okay. For example, you want to put this one AB and this one CD. The result will be, the output will be same lah. Okay. So, all right. So next we go for the K-maps. Okay, how to grouping the K-maps. Okay. So this one that I mentioned to you. If you put like this, so your answer is wrong. Okay. So that's why you have to put 1, 1 first. That is for the K-maps lah. Okay, that is the technique for the K-maps. Okay, that mentioned to you. So how to grouping the K-map. So right. So actually this one that I mentioned to you is like a spherical. That means this part. Okay, this part actually can share with this part. Okay, can share. Or this part. Okay, can share with this part. Similar like if we assume this one like our our earth, our spherical. So this one actually it can this part actually it can connect with this one, this term, and also this part also we can connect with this part. Okay, so that's why it's look like a spherical. Okay, all right. For the grouping that I mentioned to you, the grouping you have to remember first. We have to, for example, we have four variable. We have four variables. That means 2 power of 4. That means we have 16. This one, we have 16. Okay, 1, 2, 3, 4 until 16. Alright. The first group you have to, the priority you have to grouping 16. Okay. Then go for the 8. Then, okay, this is the priority, the priority. If you cannot grouping the 16, so you have to reduce the 8. Okay. If not, you cannot grouping the 8, so you have to reduce 4. If cannot, so you have to reduce 2. If cannot, so you have to reduce 1. Okay, so this is a priority lah that you have to grouping. First priority you have to grouping for the highest, okay, highest number of the variable lah. For example, we have 16, that's why you try to grouping 16. If you cannot, so you cannot, so you have to reduce the grouping for go for the 8, 4, 2 and 1 lah. And also don't worry, so this one can be redundant lah. Okay, can be redundant. For example, like this one, okay. So this one you can grouping. Okay, for example, you can grouping this one, right? So this one, okay, yeah, you can see this one, and then this one you can share, and this one, right? And this one will be standalone. Okay, so that is the grouping lah. Okay, for example, now here, so we cannot grouping 16 because of this one 0, 0. We have to grouping for the 1 because the output we use the SOP, so we have to grouping on the 1, the output 1. So the output 1 here, so if, for example, if we get the 16 here, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, so automatically we can plot here, so the answer will be 1. Okay, for example, so the answer will be 1. Totally, if all the 1, so the answer will be 1. Alright, so for example, next, okay, if we are 0, 0 like this, so we have to, next we can, okay, after 16 cannot grouping, so go for 8. So also 8 cannot, so go for 4. Okay, for group, for number of output, so also cannot. Okay, you cannot share like this, you cannot like this. It's wrong. Okay, you cannot share. For example, if I mentioned to you, you have to group 4. Okay, group 4. That's mean you have to group like this. So it's wrong. You cannot wrong. So it's cannot like this. Okay. So the standard will be like this. Standard like this, or the horizontals or vertical. Okay. The grouping you have to plot on the horizontal or the vertical. Okay. Right, so this is for SOP. SOP we grouping on the 1, and then after that you have to, okay, so you have to read from, for example, this one. Okay, so how to read the output from, okay, this one, this is our K-maps, and then we know, so just put this one. So how to read this one, so refer to AB first, okay, and then which one the same. Okay, this one the same is the B. Okay, the B we have to multiply with this one. Okay, this one in the C bar. Right, so that's why the answer will be B multiplied by C bar. Okay, so that's why you can see the answer. So next, you try this one. So first you have to refer this one. You have to refer this one. Okay, so A, B, A bar B. So this one is not it's not same. So will be the answer will be A bar B. Okay, right. So similar like this one. Okay, similar like this one. Alright, so you have to refer, first you have to refer this one. Okay, A, B bar, A bar, B bar. Alright, so this one, which one the same? Is the C. So that's why the answer will be like this. Okay, alright, so I will show another example here. Alright, so if you are grouping here for here, so this one is it's not same. Okay, so this one we A, B, okay, we have not same. So on B, that's why the answer only the C. Okay, and then similar like this one. Okay, similar like this one. We have 4 here. So the answer will be AB here. So this one cannot, because it's all not same. Okay, similar like if you have 4 here, okay, we have 4. First, you have to read here. Okay, which one the same is the B, and then multiply by this one. Okay, this one the same is the D. So that's why the output will be X is the DD. So this is the last output. Okay, so that's why no need to simplify after you get from the K-map. So this is the last result. No need to simplify. That's why it's for me is a very simple if you use the K-map compared then use the rules. So the rules you have to make sure so until at the end you cannot apply the rules, then that's the last result lah. Okay, so this is another example here. Okay, for we have 8 here, 8 here. So this one, okay, this one first we have compare here. So all not same, and then we have compare here. So will be same is the C bar. So that's why the answer will be C bar. Okay, and then another example here. Okay, so yeah, that's what I mentioned to you. So the K-map actually is like the spherical. That means here we can share to this one. Okay, we can share the both here. It's like spherical. That means this side or actually can okay can measure something like spherical can almost you can similar you can look like, so this one will be in one surface actually. Okay, so that's why first you have to read this point. So this point all is not same, and then you have to compare this one and this one. So which one the same is the D bar. So that's why the answer will be D bar. Okay, so that is for K-maps lah. Okay, the K-maps. Okay, the K-map actually first if you have a Boolean expression like this, you have to make sure it's in the standard SOP. Okay, make sure in the standard SOP, and then after you get the standard SOP, then you can draw the truth table. Then from truth table you can write like this the K-map. Okay, and then after you get the K-map, you have to grouping. After the grouping this one, so you can get the result lah. For example, this one will be B bar, A bar, C. So this is the last result for simplification lah. For example, from this one, you can see from this one, okay. So how you can use the K-map simplified into this one. So automatically very simplified, very simple lah. Compare then use, for example, you use the rule. So which one you have to make sure. So which one you can simplify. So maybe you can simplify this one because of BC. Then which one you can simplify? Yeah, okay. So maybe C, all the same. So that's why for me it's quite tough lah if you use the rule. For example, if you have the complex of the Boolean expression. So if you want to use the rule, make sure you have to make sure until the last simplified, it cannot be simplified yet. So it cannot be simplified. So that's the last result if you use the rules or De Morgan lah. Compare then if you use the K-map, so automatically this is the last result lah. Okay. Alright, so this is some example lah. I think this one you can similar like explain. Okay, so we go for the post. Okay, so today we continue our lecture is on the K-map the post. What is the difference between the SOP or SOP and the post will be output. Okay, the output lah. So will be 0. We look grouping on the 0. Okay, grouping on the 0. Okay, so for example like this. This one you can declare as the 1 lah, 1 1 1. Okay, for SOP, okay, you can see this one so this is a 0 0 0 0 1 0 1 1 0 1 0 1 so you plot here, so the output actually is a 0. Okay, 0 0 0. That's why you can grouping this one so if you're grouping this one, so you can group. Okay, this one you can group like this. Okay, okay, so this one, okay, this one and this one, for example so we have 3 lah. Okay, so right, so this some example here. Okay, so another example here, so you can plot 0 here. Okay, we can plot 0 here. First priority you have to plot for example this one we have the 8, so you cannot plot the 8 because this one 1 1 1. Okay, Okay, so we have to plot 4 here. Then after we cannot plot the 8, so we can reduce the grouping. We go for the 4. So here you can plot 4 here, and then next you can plot 2 here. Okay, and also can share. So you can see, so this 0 can share with this looping and this loop. Okay, so this is the answer lah. You can see the answer here. Actually, if we can, if you can see this one, so this is the post. Okay, you can see the post. So the post you have to write like this. Okay, in the post. Okay, in the post form. Okay, this is in the post form. Okay, but you can see the if you circle in the okay in the one here. So the answer will be, so if you read this one, A B plus A C. So actually it's the same lah. So you can see, so if you expand this one, so it will be A B bar plus A C. So actually it will be same. But so this one in the post, okay, this one you have to you put this one is the in the SOP. This one is the SOP, but uh, the the answer will be actually the same. So this one we focus on the 1, this one we focus on the on the 0. But for the post, make sure you are focused on the 0 lah. Okay, for the post you focus to the 0. Okay, for example like this, this is some example here. Okay, this one we can one looping first priority. Okay, dimension to you, so we can group 8 sorry 4. So because this one we have 16, so 16 we cannot, because this one we can assume as the 1 here, 1 1 1 1 1 1. Okay, we cannot grouping all this one to one grouping, because this one we have the 1 1 1. So next we go for 8, also cannot. So next we can go for the 4, yes, here. So we can grouping for the grouping for the 4, and then next, okay, next, okay, so 2 cannot go for the 4, so we can go for the 2. Okay, 2 here, and also another 2 here. All right, so this is the grouping. Then you can read like this. So in terms of, okay, so on the post you have to do like this: A plus B plus D. Okay, it's a different between the SOP. SOP normally like this: A B D. Okay, multiply. But for the post, plus plus here. That's the difference between the post and SOP. All right. So the last part is the don't care. All right. So what is the don't care? Don't care term is can be used to advantages on the care map, and for each don't care term, you can put as the X, okay, in the cell. So for example, this one, we can put as the this one X. Maybe we declare this one is the don't care. So this one is the, we can put as the X. Okay. So the X here can be 1, can be 0. Okay. So you can see this one. So the care map, actually there is a certain combination of the input level where we don't care whether the output is the high or the low. That means it's the 1 or 0. This one. So this one X here can be 1, can be 0. Okay, can be 1, can be 0. That's why we call the don't care. It can be high or it can be low, right? So when we when the don't care can be 1, and when the don't care can be 0. So that's based on the grouping. Okay, based on the grouping. If for example when you're grouping 1, so X can be treated as 1 to make larger grouping. Okay, to make larger grouping. Right, for example, okay, all right, so I will explain first. Okay, to make, that means the X we can change to 1, so that the that mentioned to you, so we can make our grouping larger. For example, the higher priority is the 8, or for example, if we have 4 variable, that means the higher priority is the 16. If we can we can assume X as the 1, so that means we can plot all the 16 to the 1 grouping, so that we can apply to the 1. Okay, maybe okay, and then if not advantageous, okay, it's not a function, so you can put as the 0, maintain as the 0. Okay, maybe I show here. Okay, so this is some example here. Okay, for the don't care. All right, so this one the output. Okay, we have 1 1 1 here, and then the rest is 0. Okay, here is a 0, and then this one is don't care. So when you plot to the K map, so you can get like this. Right, you can get like this. Okay, so you can see this one. So here, this the rest you can if not you can put as a 0 lah. All right. Here you can see the priority here. So we have 1 1. Okay, 1 1, and another one here. So actually we have one here, one here, one here. Okay, so the rest is X, 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 X. All right. So they mentioned it to you. So if X can be larger group, okay, that then you can add X as the one. So that's why here we put one here. We put one, we put one, we put one, we put one, we put one. That's why you can grouping all 8 here. Right, for the X, so 0 cannot lah. 0 automatically you cannot change the value for 0 or for 1. Okay, for X you can change to either for 0 or for 1 lah. So depends on the advantages lah. So that I mentioned to you, if X you can if you want to make larger, okay, so that's why you can use X as the 1 lah. For example, like this. Okay, and also this one. Okay, so we can share this one lah. For example, before this is X, so we can share as the 1. Okay, add as the 1, this X add as the 1, so you can plot this here like this. Okay, similar like this. Alright, so you can see the different. The different, if without don't care, actually it will be like this. Okay, so the answer will be, for example, we just plot this one and this part. Alright, so the answer will be A, B bar, C bar, plus A bar, B, C, D. And then if you include the don't care, so this we can simplify until this one. Okay, so that's why we can use the don't care lah. Right, so that is the function for don't care. So don't care can be 1 or can be 0. Okay, for example, like this. Alright, so we have okay, from this truth table, okay, we can K-map using the K-map. Alright, so we just plot this one 0 0 0 X 1 1 X 1. So the first priority, okay, you can first dimension you have to plot 8, so cannot lah because we have 0 here, 0, and then we go for the 4. Okay, 4. Okay, so 4, yes, because you can. So this one automatically you can change to the 1 lah. Alright, so that's why you can plot here. Alright, so another one. Okay, this one. Okay, so all the one or the grouping. So this X can be, you can consider as the 0 because no function. Okay, no function here. Okay, no function here. Right, if, okay, for example, this is X, okay, and this one we have 1 here. Okay, so also X can be 1, so we can grouping like this. Alright, okay, we can grouping like this. Okay, this means X here can be 1 because we have 1 here. For example, this example, you have 1 here, this one X, so we can assume this one X can be 1, so that's why you can plot here another 4 here for grouping larger group lah. Okay, so this is the result. So the end is just so this X you can this X you can assume as the 0 lah. Actually we have this one X X X. Okay, this one X we assume as the 1, and this one X we assume as the 0. So that is the, we call it don't care. So don't care can be 1 or can be 0 lah. Depends on the advantages lah. So if we can make the larger group so that we can represent X as the 1. If cannot, so just you can represent as the 0 lah. Okay, 0. Okay, next is the designing combination logic circuit. So this one I will go fast because I will be same on the chapter 3 lah. Okay, the chapter 3 also is the title is the combination logic circuit. Okay, actually this is the step lah. Okay, the step. Okay, for we have the 5 steps in designing the combination logic circuit. Okay, first you have to set the truth table for, but this one maybe this one not this the first step. So the first step actually that mentioned to you, first you have to check your equation, your Boolean expression. Okay, is the, I think it's the initial step. You have to check is the your Boolean expression, okay, Boolean expression or Boolean equation, okay, equation in the standard. Is a standard SOP or standard process? Is a standard. Okay, if not standard, so you have to convert into standard first. Okay, convert into the standard SOP or standard post. Okay, after you convert into the standard SOP or standard post, then you can set up the truth table. Okay, set up the truth table. Okay, something like this. Example, truth table. Alright. Then step number 2, write n terms for each. Okay, where the output is 1. Right. So this one based on your based on the Boolean expression. So where is the output? For example, this one the output. If you use the SOP, is SOP. So this is the SOP. For example, the output is the 1. For example, if we use the post, okay, the Boolean expression is the post, so we consider on the 0. Okay. For example, like this. So this is the SOP standard. SOP standard. That's why you can see we have the all element A, B, C here. Alright, and then you can write the SOP is expression for the output here. Alright, so then next you can simplify. Okay, you can simplify the output expression, because if you see this one, actually you can simplify. For example, we can maybe you can simplify for this one and this one. For example, okay, you can simplify this one. Alright, using the using the Boolean algebra rules, or you can use the K-map lah. Okay, so this is the 2 technique that I mentioned to you. So we have 2 techniques to simplify this equation to this one to this one. Okay, so this one we use the K-map. My suggestion, I use the K-map lah. Okay, for simplify this equation lah. Okay, my suggestion. That's why you have to make sure you have to know how to implement the simplified using the K-map. The K-map. If not, you can use the rule, but make sure all the last result here. Okay, for example, you get here, this is the last is the rule, and then this you cannot simplify. Then this is the last result for the using the rules or using the De Morgan. Okay, after you get this one, the simplified output expression, then you can draw the circuit lah. Okay, then draw the circuit. This one, okay, we call the combinational logic circuit. Right, so the step number 5 will be implement the circuit lah. So this one, from we have the 3 input here, so and then the output will be like this. Okay, so that's all for, I think that's all for the chapter 2. Okay, this one is the example of the donkey. So this one just skip here. Okay, will be same like that I mentioned to you. For example, like this. Okay, so this one x. Okay, this x can be add as the 1. So this one you can add as the 1. This one also 1, and then this x can add as the 0 because no function. Okay, no function. For example, this one. So because of we have to grouping on the 1 output 1, because we use the SOP. So the grouping, that's why you have to grouping here, 4 here, and another 4 here. Okay, then the output will be like this. After you get the output, then you can draw the digital circuit lah, something like this. Okay, so that's all for chapter our chapter 2. Okay, will be covered for the until the midterm test until this one, until the K-maps lah. So until K-map, you can get the last result, and then you can draw the circuit. Okay, from this one. Okay, we have B bar C plus BD. Make sure you have to know how to draw lah, from Boolean expression to circuit. Okay, at the end this is the output lah. So output will be B bar C plus BD. Okay, so this is the last output lah. Alright, so that's all for our chapter 2. Okay, our midterm will be covered until this one until the K-maps lah. Right. Okay, so next we go for the combinational logic circuit. I think the chapter 3 part 1 is similar. Okay, similar like before this. Okay, similar on the chapter 2. Alright, so maybe I just skip. Okay, and then if you refer to the slide, I think we have a lot of example lah. So for this one, maybe the example I will be just explain on the one or two example, and the rest you can try. You can try go for the example because this slide we have too many example to to give your understanding for this topic. Okay, so next we go for the chapter 3, part 1. Okay, actually chapter 3 we have part 1 and part 2. Part 2 is more on the application. Okay, the application of the combinational logic circuits. Okay, so this one is the basic concept of the combinational logic circuit is the part 1, and part 2 is the application for the combinational logic circuits. Okay, so this is you can see this one the topic for the chapter 3. Okay, I think the mention to you is the basic Okay, basic combinational logic circuit. I think I already explained on the chapter 2. So simple Okay, for example, we have the okay. So this one we have the NO so we have the NO. So we have the N, and another one we have the O. This one, for example, this is O. This is N Okay, this N is O, and then next we have the NO invert. Okay, so another one is this is the basic. Okay, this is a basic inverter basic inverter. Sorry, this is basic logic gate. Okay, we have the logic N, we have the logic O, and we have the logic inverter or not. So this one we call a not. Okay, so another one we have the exclusive O, and another one we have the exclusive no. Okay, and then we have to implementing the combinational logic. Okay, this one actually okay from this one I mentioned to you, from Boolean expression to logic circuit, and from the truth table to logic circuit. So this one actually already cover okay on the chapter 2 will be similar. Okay, will be same actually. Okay, if we give the Boolean expression, for example, if A B C plus D D plus E F, for example. So from this Boolean expression, we have to draw the circuit So hopefully you have to know Okay, for example, we have the here ABC. ABC for N, and then for O. Okay, and then this is a D. Then this is the output, and then EF. So D, we have another one here. Okay, this one EF, for example. Alright, so this is the output. We call it X here or F. Right. So this one from the Boolean expression, how to draw the circuit. Okay, the logic circuit, and then from the truth tables. Okay, before this, and then how to draw the logic circuit So also already cover for chapter 2 So this one maybe we shall go faster. Okay, and then the last the topic last for the part 1 is the universal gate. Okay, that I mentioned to you. So we have two universal gate. First we have the Nand Gate, and another one we have the NOR gate. So why we call the universal gate? So this gate can be represent. Okay, we can represent as the O, we can represent as the N, we can present as the NOT. Okay, also we can present as the exclusive OR. Also we can represent as the exclusive NOR. Okay, similar like NOR. Okay, NOR gates. NOR gate also the universal gates. That means from NOR gate we can represent as the N, represent as the O, and so on. Okay, so that's why we call the universal. Okay, why we use the NAND gate or NOR gate as the universal? Because of this gate is very cheap. Okay, very cheap and very small Okay, very small to manufacture. That's why we use the NAND gate and NOR gate. Okay, to represent as the N, O, and invert logic. That's why this one we call the logic universal logic gate. Okay, so this one I just skip Alright, so this one will be N in O logic. So this one we have the make sure I have hopefully this one I think hope all of you understand this one So from this one we can get the output here will be AB, this one CD, then the output will be AB plus CD. So this is the we call the NO logic. Okay, NO logic. Right, so this is from this one we can develop the truth table. Okay, the truth table, that means we have 4 elements here. We have 4 elements. Alright, so that means 2 power of 4, we have 16. That's why here we have 16 from 0 to 50. Okay, from 0 to 50. So if you if you cannot if you not remember how to convert into binary, you can use your calculator lah. So you can use, for example, 2, 3, 4, 5, 6. Okay, so we have 4 elements here, so you can use calculator lah. So if you convert, this one will be 1, this one will be 2, this one will be 3, this one will be 4, 5, 6 until 15 lah. So 15 will be 1, 1, 1, 1. So you have follow the sequence, follow the sequence from 0 to 15. So this means we have 16 sequence here. Okay, because of 2 power of 4 will be 16. So that's why we have 16 sequence here. Okay, and then this one you can okay, that's why I mentioned to you. So this is not okay, we have A, B, and C, D. So actually this is it's not a standard SOP. So if because of this one we don't have element CD, and this one we don't have the element AB. So that's why after you get the bullet expression here, so you can convert into the standard. Okay, standard SOP. You have to standard SOP. That means you have to multiply. For example, this one we have to multiply C and D. That means we have to multiply by C plus C bar. Okay, and then multiply by D plus D bar. Okay, you can do one by one, or you can do straightforward lah. Okay, for simplicity, maybe you can do one by one lah. First, you can do AB plus C bar. Okay, simplify this one first. Expand. Then after you expand, you can, for example, C. Okay, C plus A. Sorry, this one A, B, C bar. Then you can, okay, so you can multiply by D plus D bar. Okay, so plus A plus C, D. Okay, okay, multiply here. So plus A, B, C, D bar, and this one multiply, and this one multiply. So that you can see this one. So that's why we have the element A, B, C here, and also we have the element A, B, C lah. But this one we have the D bar, right? So and then from this one you can convert into the boolean on the truth table lah. So this one, for example, we convert into the output here will be 1, 1, 1, 1. That's why you can see 1, 1, 1, 1. The output here will be 1. Okay, and then the rest lah. So that's why if you get the boolean expression, you have to make sure. So this is a standard SOP or standard post. If not standard, so you have to convert. Okay, you have to convert this one. You have to convert into a standard SOP or standard post. Then you can develop the truth table. Okay, so next is the AND or inverts. Okay, sometimes we call the NOT gate, or sometimes we call the okay, inverter. Okay, so this one just skip this one. Just skip. Okay, this one is the basic lah. It's the basic combinational logic circuit. So we have the AND. Make sure you have to know lah. So AND, the output of AND will be AB, or you can write like this, BA. It's just same. It's the same. Or CD or DC. Okay, will be same. Or you can write like this, CD plus B AB. For example, this one also same. It's okay. For example, at the end you can get like this, A CD plus AB bar. Okay, but it's actually it's the same lah. Okay, that's why it's we call the commutative law. This is the Boolean expression law lah. You can refer on the chapter 2. Okay, then this is a exclusive or they explain on the chapter 2. Alright, so this is a Boolean expression. The Boolean expression for exclusive OR. So you have to remember lah. A B bar plus A bar B. Okay, so this is we call the exclusive OR. Okay, so next you can see the difference between the exclusive OR and exclusive NOR. Okay, this is the exclusive NOR, right? So you can see the exclusive NOR. The Boolean expression is the A bar B bar plus A B. So this is then you can see this one. So this is the Boolean expression for the exclusive NOR. Okay, so that's the difference between the exclusive NOR and exclusive OR. Exclusive OR, we have the A B bar plus A bar B. So this one is the exclusive OR. Okay, and then from this one, actually from this one you can draw the logic circuit lah. I think you can use this one. So this is the logic circuit for exclusive NOR. Okay, so why we need implementing the combinational logic circuit lah? Because we want to less propagation delay. So we want to reduce the propagation delay. So you can see this one. So I will show you how you can reduce the propagation delay. So for example, if you do like this, okay. So here, okay, you can this one also you can draw the logic circuit, and also this one you can draw the logic circuit. Okay, when you implement the logic circuit here, okay, so this is a basic lah. Basic, you implement this one, and this one you can implement like this. Alright, so you can see the reduced number of gates. Okay, this one we have 1, 2, 3, 4, 5. Okay, we have 5 logic gate. Okay, so this one will be reduced 1, 2, 3, 4. So that means our delay will be reduced because of the number of logic gate will be reduced. So the delay will be reduced. That's why the advantages of implementing the conventional logic circuit lah. So that means we can reduce the delay, propagation delay lah. For example, from this point to this point will be actually every process we have the some delay lah. So if you have more logic gate, so that means we have more delay. So that's why if we implement this one, so we will reduce the propagation delay lah. Okay, and then this is from truth table to logic circuit. Okay, all right. So actually to write the truth table, okay, write the truth table, make sure you have to get from standard SOP. Okay, make sure you can get from the standard SOP or standard post. For example, this is a standard SOP. Okay, and then after you get standard SOP, you can write the truth table lah. And then truth table, you have to refer on the output X. Okay, output X. The output, for example, if we are refer to the SOP, that means we have to refer to 1 lah. For example, this one we have refer to the post standard, that means we have to refer to 0. Okay, this one. So this is the output lah for post. Okay, and then for example, this one will be on the SOP, because this one is the SOP standard, and then the output here. So you can draw lah. You can draw the from this one. You can draw the logic circuit. I think this is also straightforward lah. You can use. Alright. So here we have the equation here. So you can use you have the OR here. So this one OR. Actually you can get like this, and then you can separate by two terms, A bar, B, C, and another one you have the A, B bar, C bar. Right. So this one we have the 3 elements here. We have the A bar. Okay. We have B, and we have the C here. So you can see. Right. So also this one, we have the A here, and we have the B bar and C bar here. Okay, and then it's how it comes. Okay, from C bar, okay, it comes from the inverter lah. Okay, inverter. So that's all. Okay, for the for draw the logic circuit lah. Okay, similar like this one. Right. So from the actually is truth table come from the equation lah, from the Boolean expression. So from the Boolean expression, make sure you have to check, is it a standard SOP or standard post. If standard, so you can straightforward draw the or develop the truth table lah. Alright, so minimizing logic and implementation. So okay, similar like topic number 2. Alright, so we have 2 techniques that I mentioned to you to minimize or to simplify. Okay, simplify the logic circuit. First, we can use the rules or De Morgan. Second, we can use the K-map lah. So my suggestion normally we have to use the K-map lah for simplicity. So to confident if the last output it can get the simplification. Okay, so that's why I mentioned to you. So my suggestion, you have to use the K-map lah, compare and use the Boolean rules, or using the De Morgan techniques and so on. Okay, right. So that's we can use the 2 techniques lah. You can see so from this equation, alright. So this is equation. Actually, this is not standard. Okay, alright. So because of this one, we don't have the element D. So we have to multiply all. Okay, have an element. So just this one we have to multiply by D plus D bar. Right, D bar here. Alright, so from this initial Boolean expression, at the end you can get like this. You can get the here lah, the equation here will be B bar C plus A C bar D, for example. Okay, so another one here. Okay, alright, so this one. Okay, so this is the X lah. Okay, and from this equation, okay, we have 1, 2, 3, 4. Okay, until then we can get like this. So the function is another one is the less, to reduce the less propagation delay lah. For example, here we have 1, 2, 3, 4, 5 gates. Okay, we have 5 gates, and then this one we simplify into 1, 2, 3 gates. Okay, that's why our propagation delay will be reduced. Okay, next we go for the universal gate. Okay, so that means we have two universals. First we have the NAND gate, and second we have the NOR gate. So okay, the both we call a universal gate. That means the universal gate we can represent all logic by AND gate and by NOR gate lah. That means the NOR gate and NAND gate can be represented as the AND, represent as the OR, represent as the NOT. Okay, so you can see this one, NAND and NOR gate is the cheapest. Okay, that is the why they use the NAND gate and NOR gate lah as the universal, because of cheapest and smallest to manufacture in integrated circuit compared them and or using the OR gate or using the NOT gate. So that's why we use the NAND gate or NOR gate as the universal, because of the cheapest, okay, and the smallest to manufacture. So there's some reason why we use the universal gates. Okay, therefore the NAND and NOR are almost always used in the practical circuit design. That's why you can see a lot of your design, okay, on the digital. So normally they use the NOR as NOR or NAND gate. Okay, so the De Morgan theorem is most commonly used to transform all logic gates to NAND gates and to NOR gates. Okay, for this one, we have to use the De Morgan theorem. So, okay, you have to remember the De Morgan theorem. So, the basic of the De Morgan theorem: break the bar, change the operation, operator. So, this one, okay, this is the first theorem. So, you have to break the bar here. You have to break on the operator here, break the bar, and then change the operator. So, we change to multiply. Then, similar like this, we break here on the operator here, and then we change the operator. So this is the theorem lah. Theorem 1, theorem 2 for De Morgan. Alright. So this one is the how the NAND gate can be represented as the inverter. Okay, or can be represented as the AND, can be represented as the OR gate. So this one you have to know lah. Okay, so for example this one, okay, if we have this one, alright, so this is NAND gate. Actually you can, okay, so the answer will be get A lah. Okay, actually, so we here so you have to remember so okay, we have A here. So actually it's the count with your A. Alright, A multiplied by A. So actually A multiplied by A is the rule will be A. So that's why you can combine together. So that's why here will be A, and then output go for the inverter, so will be A bar. So that's why you can use NAND gate as the inverter. Okay, to represent the inverter lah. So that means if we have one NAND gate here, so that means our input can be as a inverter lah. That's it. So next, if we use the two AND gate, two NAND gate as the AND gate. Okay, so this is a NAND gate lah. So we have the AB here. Okay, so actually this is the inside this one we have the AB. Okay, and then we have the inverter. So that's why the output here will be A B bar here. And then go here. So this one we have the A B bar here. Then inverter here. So we have double bar lah. Okay, we have the A B here double bar. So on the row, so double bar will be cancelled out. So that's why the output last we can get the AB. Alright, so similar like this one, this NAND gate, similar like AND gate here. Okay, so this is for OR gate. Okay, for using the NAND gate, so you have to remember lah for to implement the OR gate, so you have 3 NAND gate. Okay, we have 3 NAND gate lah. Okay, so this one we have the A here. Alright, so this one will be A bar, and then this one B, and then this one B bar, and then enter this one, and then you can get the C. So this is similar like A. That's why here we have to use the De Morgan. So this one we use the De Morgan. Break, okay, break the bar. Okay, break the bar here, change the operator. So yeah, break the bar here, change the operator to plus. So that's why you can use the De Morgan on the to convert, okay, from NAND gate to represent as the OR gate. And then you can see also the NAND gate also can represent as the NOR gate. You can see this one. So this one you have to remember okay, you have to know how to develop the NAND gate to represent as the NOR gate. Okay, we have 1, 2, 3, 4 here. Okay, this one for NAND gate. So next we go for the NOR. NOR also the universal logic gate. Also can represent as the emitter, represent as the OR and AND gate, but you can see the difference between the today I will show you what is the difference between the NAND gate and OR gate and the NOR gate. So the emitter is actually the same. So you can see. So for NAND gate actually is like this same. Only one. Okay. You can, for example, A here. So similar like is the NOR gate. So NOR gate only one. Only one. Okay, so only one that you can present as the inverter here. Okay, if you use 2 OR gate here, connect in the series. So this one we can present as the OR gate. You use the NOR gate. But if you use the NAND gate, if you use the NAND gate, so you can represent as the N. Okay, represent an N. That's the difference. For example, for you have the NAND gate here. Okay, so this one will be present as the N. Okay, this one will present N gate. But if the NOR gate here connect in the series, so this one is connect in the series, so this one can represent as the OR gate. So that's the difference between the NAND gate and NOR gate. Okay, you can see the for the NOR gate to represent as the NAND gate. Okay, this one for if you use 3 NAND gate, so actually it's the OR gate for the if you use the NAND gate. So you can see this one for the NOR gate can present as the NAND gate. So we have used 3 NOR gate here, right? Similar like, okay, for example, we have the NAND gate here. NAND gate here, okay, A and then B. Right. So this one another one NAND gate. So this one we can present as the OR. Okay, OR gate for the NAND gate But for the NOR gate, so this one can present as the AND gate. So that's the difference between the NOR and then the NAND gate So but the emitter will be same The emitter will be same. Okay, and then this is for NOR gate can represent as the NAND gate Can represent NAND gate. So this one if you have NAND gate, so you want to change to NAND gate, so you can use this NOR gate So this one normally for the question here, normally we give the at the end, for example, normally like this. So if you get like this, the last output here, okay, this one. All right. So normally this question will be ask you to you have to draw using the NAND gate or using the NOR gate. So this one So normally the question for example for the midterm or for the final, actually for the last output here, you have to draw in the NAND gate and NOR gate So you can see this one. So if you use the NAND gate, that means you have N here. So how about N? So you have to refer N how it look like. Okay, represent using the NAND gate or using the NOR gate. So that's we will cover after this Okay, and then okay, so this is a mixed logic I mentioned to you. Mixed logic is if you have the Boolean expression, okay, that the simplified that I showed to you before this. So you have to draw using the NAND gate, or you have to draw using the only the NOR gate. So here, for example, enable component reuse, okay, and then allow digital logic circuit designer to implement the combination logic circuit with only NAND gates. That means if you get the simplified like the equation here, okay. So this one, that mentioned to you. So this one we allow only, we have to use the AND gate only, or we have to use the NOR gate only. So that's why here you have this logic circuit, you have to change to NAND gate, or you have to change to NOR gate. Okay. All right. So next, okay. So this is some that means to you. That is the comparison. Okay, comparison between the. Okay, you can see this is the NAND gate, and this is the NOR gate. All right. So you can see. For inverter, I think it will be same. Inverter here will be same lah. Okay, just this one for NAND gate and this one for NOR gate lah. Okay, but you can see on the this one for N, this one for N. All right. So, but on the NOR, there will be represented as the OR gate. So that's the difference lah. And then for this one will be OR gate, but for the NOR gate will be AND gate here. Okay. The rest will be same lah. So you can see this one will be NOR. Okay, we have similar. We have one something like this. We have 4. Okay, so similar. So this one will be NOR, and this one will be NAND. Okay, right. So this is another. You have to normally for the test. Normally we just use the basic lah. The basic. Normally we use the AND, OR, and NOR lah. Okay, for example, okay, this some example lah. We have, okay, I show some example here. Okay, so we have a simple example. Show some simple example. We have A, B. All right. Okay, and then this is a not lah, not okay. So this one we have to use the NAND gate. Okay, we have to use NAND gate lah. NAND gate. We have to use NAND gate. Okay, so we know this is OR. Okay, this is OR. Which one OR? So this one. So you have to draw lah. So you have to draw the OR here. Okay, so this is A, and then another one is the B. Okay, so and then combine to another NAND gate. Alright, so this one will be here will be A plus B. Okay, A plus B, and then we have to go for inverter. So we have inverter. So another one inverter. So this one. So just enter another one here. Alright. So that is the NAND gate. That means from this circuit, okay, the output will be A plus B, A plus B bar. Okay, and then this is the output will be A plus B bar. But all the component we use the NAND gate because that mentioned to you. So why we use the NAND gate? Because the NAND gate is the universal, and then this is very cheapest, okay, cheapest and smallest to manufacture. That's why all the manufacturer using the NAND gate or using the NOR gate to represent as the O, represent as the N, represent as the NOT gate lah. Okay, so this is some example. Okay, you can change one by one. For example, we have OR here. Okay, we have OR here, so you can change part OR, and then you can add. Okay, you have to convert into the NOT. Okay, for example, another example here. Okay, if you have the N, what happens if you have N? So that's why you have to double check lah. If you have N and NOT here, actually this one you can combine into the like this lah, into the one. Okay, the NAND gate. Okay, but if you can if you do one by one here, actually, so this one, then NAND gate here. This one A B. Alright, so this one A B lah, A B. Okay, this one A B. Alright, this is NAND gate. Okay, so we have another one here. Okay, actually this is okay until this one. Right, so actually this is a N gate. Okay, not gate. If you put another one here, so that's why you have to double check, because actually this one we can simplify into At the end, the answer will be A, B, Nand Gate, and then this one and B. Okay, so like this. Okay, like this. This is the answer lah for this one. Okay, so next maybe you can go for the example lah. Okay, so you can see this one. So how they use the De Morgans. Okay, De Morgans to differentiate the Nand Gate function or the negative, okay, as the negative or, right? So okay, maybe we go for the example. Example. Okay, so for example, we have this one. We have this equation. Okay, we have this bullet expression. Okay, we have, okay, that actually for mixed logic we have two techniques lah. We have two methods. So if you either one lah, you want to use the first method or second method. So for me, normally I can use the first method. Is easier lah. Okay, the first method, first technique, the first step. The first step you have to draw the and, or, and not lah. Okay, so okay, for example, make sure this one you have to know lah how to draw like this. Okay, so for example, first step you have to draw the Boolean equation consists of the and, or, and not get logic. And then you can convert one by one. So you can convert one by one. Convert into, for example, convert into okay, this now they want to use the Nand Gate. Okay, so you can convert into one by one. This one by one, and then this one by one. Okay, this one here maybe you can convert into n maybe like this. So and the A B. Okay, so we have the A B here. Okay, for Nand Gate here, for example, Nand Gate for this one using the Nand Gate, so typically we can get like this. This one is the D. All right. Okay. So this is the step lah. Step one. Okay. The step two. Okay. Another step, you can add the bubble lah. Add the bubble at the output of Nand Gate. Okay. This one is similar like you can use one by one lah. Okay. And then step three, add bubble at all input of the OR gate lah. Okay. But for me, if you use, you can use like this lah. Okay, you can use one by one, step by step lah. So you can convert into this one, convert into this one, and then convert this one, convert this end, and then convert into this OR gate to the using the NAND gate lah. So at the end you can get like this. Okay. Alright, so this is the result lah. Okay, you can see this one. Alright, so this is the here. Okay, and then this is the NAND gate. Okay, and then AND gate here. You can refer, and then this is the NOT. Okay, and then this is the NOT. Okay, dot here, and then this is the NAND gate here. Okay, and then go for the NAND gate here. The NAND gate, and then this is usually the OR gate here. So because of this one, this is the OR gate lah. Okay, the OR gate. Okay, for the NAND, you can see on the notes. So like this, you have the like this lah. We have bubble here. Sorry, we have the bubble here. Bubble. Okay, so this is for example A B. Okay, so something like this lah. That's why here. So for OR gate, and then this is for NOT gate here. Okay, you can do step by step lah. You can do step by step. That means you can do one by one lah. Okay, for example, first here you can put on end here. Okay, and then change to using the NAND gate, and then next you can change the NOT gate to using the NAND gate here, something like this, similar like this. For D, convert into the NAND gate using this NAND gate here, and then this one will be add lah. Okay, will be add. Okay, this one for the add lah. Okay, using the NAND gate for this. Okay, for this one, the AND gate here. Okay, so another method. Okay, another method. They use the De Morgan lah. Okay, De Morgan. So they use the De Morgan. So you can see So De Morgan, remember break the bar, change the operator. So you break the bar here. Okay, change the operator lah. So be like this. Okay. will be like this, will be like this. And then you can see, then we can put double bar. Okay, we can put double bar. Actually, so if you put double bar here, it will same like this. That's why you can put double bar here. Okay, double bar here. So we have simplified, so it will be like this. That means, for example, if you put double bar here, actually it's the same like A. Alright, so that's why you put double bar here. Okay, so that is the first step lah. The first step for the method number 2. Then you can draw skirt step by step, similar like step 1 lah. So for example, we have the BC, you have to convert into the BC bar. Okay, and then double bar, so you have to put inverter here. This one you can get AB bar, and so you put another one here. So will be BC double bar here. Actually, it come here with BC. Okay. At the end, you can get something like this, BC. This one also BC, because double bar will be BC. And any question? Alright, so next, similar like for D lah. So this one is the D bar. Okay, D bar, and then this one we have to put the AND gate here. Okay, AND gate, the NAND gate here. So it will be like this lah. Then after that you can combine lah, and then after draw the circuit step by step, you can combine the circuit, will be like this lah. Okay, I think will be similar like before this. Okay, the answer will be same lah. Okay, so this is another example. Okay, another example using the second techniques. Okay, first they convert into the using the De Morgan, and then after using the De Morgan, you can draw the first step by step lah. So first using the BC here, and then using the inverter to convert into the B bar, double bar here, similar like this one, until you can get the answer like this lah. Okay, this one you have to try lah. This one you have to try. Make sure you have to. This one you have to remember this one. This one I'm not sure it's given or not on the final. So normally I think it's not given. So you have to remember lah. For example, okay, this is very important for you. If I think this one will be covered on the final exam lah. Final exam. So because this is chapter 3, not covered on the midterm lah. So you have to remember lah. From, for example, we have explain on this part lah. So we have some circuit some circuit here. Okay, for example, this one, some example here. Okay, maybe I put another one inverter here. Okay, inverter. So this one will be A, B, and this one C. So the first step you have. Okay, so the question want to use the NAND gate. NAND gate, the NAND gate. Okay, so now we have we know we have the OR gate, we have the NOT gate, we have the AND gate. So first we have to go one by one for this one, NOR gate. So this is the NOR gate. So maybe you can draw. This is too many. Okay, so okay, for example, I put here. Okay, so this one will be the gate. So and then C will be, and C we have NAND gate here. Okay, this is C, and then go here. Then we have the AND gate. Okay, the AND gate here. So will be AND gate here. Right. Okay, so that is the answer lah. With AND gate, and then you can double check lah. So either you need to put another one here. Okay, another one here. So that is the answer. For example, this one. So that means here. Okay, this part will be on the OR. Okay, you can put that, for example, like this. Okay, show like this. So this is okay. So yeah, I mentioned here. So this is the AND gate. Okay, so this is the AND gate. This is a NOT gate. Okay, this is NOT gate, and then also this one is the NOT gate. Okay, the NOT gate, and also this term will be OR gate here, OR gate here, and then last one is the NOT gate lah. Okay, you can see so just draw, you can draw one by one lah, something like this. Okay, that is the step lah from the logic circuit. First, we have two technique lah. So first you can draw step by step. That means first you have to draw using the basic. Okay, using the OR gate, using the AND gate, using the NOT gate. Then from this logic, the basic logic circuit, you can draw the basic every component. For example, for OR gate, how you can draw OR gate based on this equation lah. Okay, based on this theoretical based on this equation. For example, if you use the OR, okay, for the NOR gate, or something like this. For the NOR gate, you have to remember the NOR gate. So just you do separate lah. For example, this component you have to use the OR gate, and then go for the AND gate. Okay, maybe you have like this lah. This equation. Okay, we have the OR gate here. So maybe here A and B, and then another one we have the okay, maybe CD. Okay, and then plus maybe N. Okay, and here. Right. So the first step you have to convert into this part. Okay, into the OR, something like this, and then this part for N. Okay, you have to convert into like this, and then the next part you have to convert into like this. For the N like this. Then you can combine the three for the NOR gate lah. Combine for the three component lah. Maybe you can get component 1, component 2, component 3. So combine will be the last answer for the using the NOR gate. So that is some example. So that's why here, if you refer to this slide, so too many examples. So after this, maybe you can go through lah. So this one I just skip because of this one is just a example lah. So this one also example example. Okay, also this one it shows some example. Okay, another example. So this one another example that you can check. So we give the final answer, and then make sure you can double check with technique 1 and technique 2, or another technique you can use that mentioned to you. You can use the one by one, and then you can double check lah the answer. Normally you can check on the last output lah. So the output here, you get like this or not. If not, so that means our logic circuit will be wrong lah. That's why you have to double check lah. Is on the last output for the Boolean expression here. Okay, so here you can see this one. Also, we have another example lah. So on this slide, actually you have too many examples lah. Example here. So you can, after this you can go. Okay, you can go study in this example. Example here. So this one, I'll just skip this one because this is some exercise. Okay, some example. Okay, we have the this Boolean equation. So first step, okay, you can use the technique 1, technique 2. Okay, first step for technique 1, maybe you can draw the basic logic using the AND, using the OR, using the NOT. Then you can convert step every component into the NAND gate. Because the equation you have to use the NAND gate only. That's when you can see this one, all the component will be in the NAND gate lah. NAND gate. Okay, so this one also example right? So this one I just skip this one so you can go through after this. Right, so this is also example how to convert into the NAND gate or using the NOR gate using the NOR gate here. Okay, so you can see we have this like a lot of example lah. So that's why you can after this you can go through lah. That's why here so some of the component after you put here, so you can ignore lah. For example, okay, I mentioned to you. Okay, for example, we have the for that's why you have to double check in this some example I want to show you. Okay, for example, we have the AND, we have the NOT gate here. Okay, we have for example AB. Okay, if we draw like this. Okay, so this part and this part, for example, this some example. Okay, for AND gate, Okay, AND gate using the NAND. Using the NAND, I will show the NAND. Okay, so the NAND. Alright, so this is AND gate. So this is the AB. Alright, so go for another one. Okay, another one. So this one is represent as the here N. This represent as the N. Okay, and then so this one we represent as the N gate. Okay, so this is the N gate. Sorry, N gate. It's a NOT gate here. Okay, NOT gate. So this one will be NOT gate. Alright, you can see this one. Alright, so if we combine this one, it will be like this. Okay, but you have to double check. So that's why some of the part you can combine together into one component. So for example, okay, if you put like this, so this one will be okay A, B, bar. Okay, and then convert into inverter here will be A, B, double bar. That means here will be also A, B. Okay, but if you put another one here, inverter here, so will be the answer will be A, B, bar. So it's wrong. That's why this one actually you can combine into one. So the answer will be like this. A, B is not is the NAND gate. Okay. Okay, so something like this. That's why the last output will be A, B lah. Okay, similar like this one lah. Okay, if you want this one, okay, the bar, so you can put another one lah. Okay, that's why some of the bar we can ignore lah. Okay, so this is another example that you can try after this. Okay, so they use the NOR gate. Okay, so for simplicity, for example, that I mentioned to you, so you can go one by one lah. So this one change to NOR gate, and then this one change to NOR gate, and this one change to OR gate. This one change to AND gate, and so on. And then you can combine together lah. Okay, combine together. Then the last output you can get the result lah for the using the universal gate. Okay, so alright, so I think this one you can see this one you have this is some example lah. Some example. Okay. So this one some example. Okay. Alright, so this one okay using the NAND gate and using the NOR gate lah. So I think that's all for today. Okay, also this one also last you have to implement the simplified function using the NAND gate or using the NOR gate lah. That is normally on the final exam on the midterm lah, but this one midterm not cover lah. The midterm until the KMAT until the KMAT. Okay, I think that's all for today. Alright. So actually the chapter 3 part 1 is more on the combination logic circuit, but normally we use the NAND gate or you use the NOR gate as a universal lah, so that this universal can represent as the OR gate, it can represent as the AND gate, or can represent as the inverter. Okay, inverter gate. Okay, that's all I think for today. Alright, so before that, before I forgot, so I have one announcement. So tomorrow we have the what we call it the quiz. Okay, tomorrow we have the quiz. Okay, we have the take home quiz lah. Actually, it's not the quiz. Actually, it's a take home quiz. So tomorrow morning we have the quiz on the Teams. Okay, so will be appear lah. So will appear tomorrow. Alright, so you have to answer. Okay, you have to answer and then upload the your answer into Teams lah. So already have I will create the assignment on the Teams, so you can submit through the Teams. So for the tomorrow. So tomorrow morning we have the simple quiz. I think simple quiz that actually is the previous midterm test. Okay, I just take the previous midterm test as your quiz. That's why you have to study at least you have studied the the chapter 1 and chapter 2 lah. Okay, until I think the quiz tomorrow is similar like midterm test. I just take from the previous midterm test and then and present as the quiz for your quiz. And then you can submit until this Sunday lah. So it's not immediately you have to submit. Okay, so you can open the books. Okay, you can discuss with your friends. Okay, and then you have to submit on the Sunday. Okay, Sunday before 12 p.m. lah. Okay, so 12 p.m. Right, so that is the for an announcement. So tomorrow we have the no class on no synchronous class. We have the synchronous class. That means we have the quiz. Okay, this quiz I think you can score lah because this quiz is the open book or open discussion lah. So you can discuss with your friend. Okay, and then don't copy lah. I think you can discuss, but don't copy. Make sure you understand. Okay, every I think we have 3 questions on the quiz. Okay, related to chapter 1 and chapter 2. I think will be similar like our midterm test. I'm not sure, so because I don't get the any midterm equation yet. So if I get, so maybe I can give a tips. Okay, now I cannot give a tip because I don't get any information about the question. So but normally we'll be cover on the chapter 1 and chapter 2. So similar like our quizzes. Okay, our quiz tomorrow. So we have 3 questions will be covered for chapter 1 and chapter 2. Chapter 1, chapter 2. And then you can discuss. But make sure you understand. So you can discuss with your friend, okay, or you can open the books, okay, refer the books, and then you have to submit on the I give you Friday, okay, three days, and you have to submit until Sunday, okay, until Sunday midnight lah before. Yes, tomorrow no class. Tomorrow just a quizzes, okay, just a quiz. So you have to answer the quiz. Okay, first you have to download. You have to download the question on the team tomorrow. Okay, will be appear on the 8 o'clock. Maybe just have the delay, so maybe around 5 or 10 minute delay. So don't worry. So you can get the equation for the quizzes. Then you can try answer. Then before Sunday 12 p.m. you have to upload through team lah. Okay, all right. So that's all for today. I think we stop here. Okay, so tomorrow, so actually, if 6 May, so we have another 2 weeks. Okay, we have another 2 weeks to prepare for our midterm test. Hopefully, for the midterm test, you have to score. You have to score the midterm test. That's why for the quizzes, I just give for the previous midterm lah. I'm not sure. So is it the same question or not? So hopefully, if the same, so it's a bonus for you. So that's why you have to, maybe you can make sure you have to understand. You have to understand the every question that you have to answer. Okay, so that if you get I think the question is almost similar because it will be covered for the chapter 1 and chapter 2. I think it's almost similar. Every semester will be almost similar, but maybe the connector change the value, for example, and then change the circuit, but the basic question will be same. So that's why tomorrow you have to get the answer. Okay, get the question. You have to try to answer first. Okay, if not, you can discuss or you can open the books. Then you have to submit on the Sunday lah. Right. Okay. So that's all for today. So if not any questions, so I will stop here. Okay, right. Okay, thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh.